So today we will learn how to create a time series map. So for example, if you see this map, if you have images of different timelines and how to create a time series animation like this, or the format that you can download it is GIF, right? So today we will try to understand how you can create something like that from data. Okay. So we will be doing this exercise, and in this exercise we will get a practical example of this, how to do this. So I'm sharing the link with you. So if you do it along, it would be really nice. Mhm. So if you read, it says any meeting time series data. Now, any data which is having a date of uh, capturing it, or a date of incidence to it, right? So it becomes a time series. So, for example, if there is a flooding event, I have an image of 5 days ago, and the flood happened today, and then I have an image today, and then maybe after few days. So I have an capturing moment where I have captured the flooding event. Okay. It can be raster data, it can be vector data also. So, for example, if there is a point which has rainfall in it stored every day, maybe not rainfall, just for example, AQI. Okay. Every day there is a point created, maybe a vector point that is being created for a data set somewhere, which stores the AQI for that location every day. So that is a vector time series data, right? Now, time is an important component of many spatial data sets. Along with location information, time provides another dimension for analysis. This is important. Time provides another dimension for analysis and especially visualization of the data. If you are working with data set that contains timestamps means the time of collection, or have observations recorded at multiple times steps, you can easily visualize it using temporal controller. Temporal controller allows you to view and export slices of data between certain time intervals that can be combined into animations. Now, I have shared you the link already. Just go to this get the data and you will find this line. For convenience, you may directly download a copy of the above layers from below. So download these two shapefiles. Once downloaded, uh, extract them. Okay. So the first step is, in the QGIS browser panel, locate the directory where you have saved the downloaded data, expand the data, or what you can do is just directly look for this shapefile that we have downloaded. Okay. And in both the data that we have downloaded, there must be a shapefile. So we downloaded this and this. So in this we have this shapefile. Just simply drag it to your QGIS and then go to the other folder. Simply drag this shapefile to the QGIS place the events above the. Now, you see there is some kind of data here. Okay. I will tell you what the data represents, but one of them is the world map. Okay. Now, once the layer is loaded, you can see the individual points representing incidents of piracy locations. Now, what happened? Because if you see, all the points are in ocean area, sea area. None of them is exact. One or two points may be on the land, maybe due to some error or something, but most of them are in the ocean. Okay. So these are all pirate events. What do you mean by pirate events? That you had a normal ship going here and some pirates attacked. Some unknown goons using a boat or ship attacked that boat. So these are all points where some pirate event happened. Okay. Now you can see the density of it is much more where, right? So for example, here it is very less, but the density is so much around here. Okay. Whereas it is very less around Australia. Rather than individual points, a better way to visualize this data is through a heat map, right? So individual points are difficult to understand and visualize, right? To visualize it better, what we can do is we can create a heat map out of it. Okay. Select the ASAM events layer. Click the click the open the layer styling panel button in the layers panel. Click the single symbol drop down. So simply select this layer. Go to the layer styling panel that is here in the corner. Click on it and click the single symbol drop down and choose heat map in it. So choose heat map in it. Okay. And now next select the Viridis color ramp. You can choose any color ramp, but this one is more preferable. Okay. So in the color ramp, so we will, if we make it opaque, we can understand where the density of the parade events is more. Okay. So the next step is, sorry, I pasted it. It did not forgot to press the enter button. Okay. Let me state it again. Just go to the link, download these two shapefiles. Once downloaded, extract it. So both of them has one shapefile in it. Drag that layer to the QGIS and something like this will open. So once you reach this step, just let me know if you're doing it parallel. Just let me know once you reach this step. Okay. And then I will proceed. Uh, how many of you are doing it parallelly? Is any Imran is doing it and who else? Okay. Okay. So just reach this step, add both the shapefiles. So once you add both the shape files, you have to click on the ASM events. Okay, so you have to click on ASM events. So once you click on this ASM events, you will find this layer styling panel here. Okay, this one in the corner, that is the layer styling panel. Choose this. After choosing, go to your heat map. Go to this. It will be single symbol here written here. Single symbol. It would be like this. Select the single symbol and change it to heat map. Change the color ramp to Viridis. Okay. So now if you remember in heat map from the one example that we did about the police theft, yeah, if you remember, there is a radius to it. So this radius is important to create this clusters, right? So let us, for this example, we are going to take the radius value as 5. At the bottom, expand the layer rendering section, adjust the opacity to 75%. Okay. So first, change this radius value to 5. Make sure it is millimeters here. Okay. And then go into the layer rendering option. Choose 75%. Just simply write 75 here. Okay. So now you can see the heat map over the world map, right? You can better visualize the piracy points. Got it? So now if you have to visualize it, you can say, okay, this, and this is the zone where maximum piracy happens. Okay. Now, now let's animate this data to show the yearly map of piracy incidents. So right click on the ASM events. Now, if you remember, there are two shapefiles. One is the world map. One was the point data that we converted into a heat map. If you open its attribute table, so there is the date of incidents also here. Okay. So the piracy event happened on this date. So now we have a date data attached to this point layer because of which we can visualize it better. Okay. And how I will tell you. Now right click on it, go to properties. In the layer properties dialog, select the temporal tab and enable it by clicking the checkbox. So you will find at the end here on the very last, here you will find this temporal. Select this. Okay. In temporal, check the dynamic temporal control. Okay. So everyone who is doing it, are they along with me or are they left behind? Should I wait? Or are you, have you reached the step? Okay. So just let me know where are you. I can help again. Okay. Once you create the heat map, put the radius as 5, go to layer rendering, choose the opacity as 75%. Write 75 here. Okay. If your live update is not ticked, tick it. Otherwise, click on apply. So if you have live update, it will automatically save it. Now, right click on the ASM events, go to properties, and in temp, there is these tabs. In these tabs, you will find one tab called as temporal. Okay. Select this temporal tab and check the dynamic temporal control. So whenever your data has dates in it and you want to create some uh, time series, you have to work with this temporal tab. Okay. The source data contains the attribute date of occurrence, representing the date on which the incident took place. This is the field that will be used to determine the points that are rendered for each time period. Select single field with date and time. Go here in configuration, select single field with date and time. Now, because this incidence is occurring once, right? There is one date. Maybe you are working with a data which has a time range. Maybe you are working, for example, for a you have points of around the world where film festival occurred. Film festival happened. Okay. And film festival is maybe not for 1 day, it was a 10-day event. Okay. Then there will be a start date and also there will be a end date. So in that case, you can see here are the other options. Separate fields for start date, end date, separate fields for start and event duration. So you have many options here. Okay. So for our current operation, we will be choosing the single field with date and time. Okay. Now the field here, it should be the one that contains your date. So for us, it automatically will select because we have a single field only. If there were 2 or 3 fields having dates, then we would have gotten the option here. Okay. Now, this event is not of duration, it just has a date. If it has some duration, you can add the duration here. Okay. Once you click OK, you will see that there is a clock here. Okay. So now we will be using this clock. Now a clock symbol will appear next to the layer name. So because we turned on the spatial temporal, you can see the clock here, which represents that your this layer is a time-based layer. Okay, whenever there is a clock, maybe someone gives you some shape files, and when you load them, a clock shows appears here. It means they are dynamically turned on. In their layer properties, the temporal feature has been turned on. Okay. Click on the animated temporal navigation. First, click on this button. So once you click on this button, this temporal controller will appear. Okay. It is currently disabled. So once you add it, you have to activate the animation controls. Click the set to full range refresh icon next to the range to automatically set the time range to match the data set. So first you have to activate by clicking it like this. Now the other tool set will appear. Once this appears, this currently is not calibrated according to the dates in this shapefile. So to calibrate it, automatically calibrate it, you have to press refresh. Now it has taken all the dates from starting to end in this. Okay. So you have to first refresh it. Now you are ready to preview the animation. Set the step as 1 year, then click the play button to start the animation. Now, because my data, if you see here, it is more diverse through years. So 2013, 15, 17, 2000, 2001, right? It is occurring over the years. So I am taking the step as 1 year. Okay. If if your data is maybe all your data is occurring in 1 day only. Okay. And then you can take the steps in minutes, hours, seconds, milliseconds. Got it? So you have different options here to select the step. For the current extent of our data, years is the most right choice. So we choose years. After choosing the year, we have to click the play button to start the animation. So if I click the play button now, so this will show you over the years, the data is coming here. So this is how the incidents occurred over the years. Okay. Clear to everyone until this point? Now, if the animation is too fast, you can adjust the frame rate by clicking temporal settings. This one. So if you want to make it slow or fast, you can change the frame rate. Okay. It would be helpful to also display a label showing the current time of the frame on the map. We can do this by using the built-in title decoration. Okay. Now we have the data. The data is being shown, but it would have been more visualizingly it would have been more detailed if there was a year date mentioned here. Okay. Now, for example, I am seeing that data is varying, but there is no mention of the dates or years. If that was here also, it would have been more helpful on the map itself, right? So there is this option, go to view and decoration, view and decoration, and go for title label. Okay. Enable this title. So once it appears, you will see an empty space here. You need to click on this edit an expression. So click on this expression box will appear. So there is this formula. So you have to see that this formula, you copy it and paste it here. So this formula, if you want to know more about it, if you, for example, we are copying it from that website, but if that formula was not available to us, we could have simply just looked it here. So for every, maybe if I select year, the formula of year may be somewhere here only. Week is here. So you can select the time range here also. Now this expression, when you click OK, select the size as 25, click on font, make the size as 25, click on background bar color, choose the opaque color, but it is, if you want to change the color to maybe some other, for example, this is purple. So the contrasting color that will suit will be yellow. So double click on, so you can choose yellow and placement bottom right. So you can place it anywhere, left, right. Okay. So maybe bottom right and click on apply and OK. So now the year appears here, right? Once the parameters are set accordingly, this will display as shown. To export these images and convert them as GIF, select the export animation save icon in the temporal control window. Mhm. Simply click here. Choose the output directory wherever you want to save. Under the extent, select the calculate from layer because the world map is the layer, right? So in the extent, in the layer, click on drop down and select the any 10-meter land. Okay. And simply click on save. Once the export finishes, you will see PNG images for each year. So just go to the folder that you just created. And if you come here, you will see that there is a image generated for each year displaying the events. So now you have to simply look for a GIF creator. So that is a GIF converter. Uh, the one that they have written down here is called as Easy GIF. You can simply click on this, upload the photos. Make sure before uploading you sort them. Sort by name and upload. So if you want to change the delay or frame seconds, you can do it here, or you can simply just go and click on make a GIF. So if you think it is fast, you can change the frame here. Okay. The delay you can increase to 40, 60, right? But it is giving the year-wise representation of the data. Got it? So you have created your first time series map. Any doubts in this? So people who were doing with me, were you able to create one? Good. So the next thing that we are going to talk about is something called as terrain analysis. Okay. It may be a very basic thing for some of you, but if you are new to GIS, you need to know about it. You need to understand what terrain analysis is and the related features. Okay. So, by definition, terrain analysis is the analysis and interpretation of topographic features through GIS. So, no, so what happens is for vector, what you have to do, maybe if it is polygon or points, you have to add a date file. Okay. But for raster, it is very simple. You can just a very good idea. You can create a land use land change of the same, and you can create from the vector to this. But also, what happens is because you cannot add a timestamp like that in the attributes for the raster, you have to simply club the images and create it into a GIF. Okay. Now, you all must be knowing about a digital elevation model, right? So, what is a DEM actually? What is the basic of DEM? I mean, how to define a DEM? So, if you remember, if this is a normal imagery, right? There is pixels inside of this image. So, every pixel has a, yes, very good. So this just consider this to be a normal imagery, maybe your RGB imagery or a single band imagery. Now what happens is each pixel has a brightness value, that is the reflectance that I told you. That is why we are able to see that image. But what if instead every pixel, instead of this brightness value, what if it stored the elevation of that point? So maybe let me represent this 30 by 30 meter with a single elevation and represent this as elevation. So instead of brightness value, when I put the elevation value of this area, okay, the mean elevation of this pixel, and all the pixels have the elevation value, then that is called as digital elevation model. Okay. Now, if you look at this image, just like them, there are two more terminologies that is called as digital terrain model and one is called as digital surface model. But all of them represent elevation only. Okay. So their pixel values have elevation only. So let me give you an example. A DEM looks like this. Okay. So you can't actually understand what is on the ground, what objects are on the ground, because we don't have brightness values. Instead, these are elevation values. You can see where there is depression, where there is low relief, where there is altitude. So we have chosen the color so that the white represents the elevation, higher places, whereas the black represents the lower elevations. Okay. So if you click on any point here, you will get a elevation value, the elevation of it from mean sea level. Okay. So every point has a elevation. So if I go to these dark points, you will see they are of low elevation, whereas this white is of higher elevation. Okay. So this is a digital elevation model. The digital surface model, the digital terrain model, they are also of the same type. Their pixels also represent the elevation. But when creating them, there is a basic difference. So if you see here, can you spot the difference between a digital surface model and a digital terrain model? Right? You can easily spot it. So there are natural as well as anthropological structures. A house is built by humans, trees. In a digital surface model, it also takes the elevation of the structures, natural as well as anthropogenic. Whereas when we are creating a digital terrain model, it does not take the trees or buildings, it cancels them out. So, for example, if you have a digital, you have one digital surface model and you have one digital terrain model. Okay. Now there is maybe a house here. This is a vertical image. You are seeing the house from the above. So this is a house here. Okay. And the ground is flat. The ground here is flat. But the ground is at a elevation of 300 meters. And the house is 5 meters above it. Okay. So in a digital surface model, the elevation at this pixel, the elevation here would be 305. Whereas the elevation in a digital terrain model here, because it will ignore the house, it will be 300 itself. Okay. I hope this is clear. Now, let me just basically tell you the definition. Digital elevation model serves as the foundational model, providing a comprehensive representation of bare earth elevation. So, digital elevation model is also providing a comprehensive representation of bare earth. This model includes natural terrain features excluding any structure or vegetation. Okay. So there was once a question, DEM, it was in the GATE examination. DEM is more similar to DTM or DSM. Okay. So it says uh, it excludes all the structures and vegetation. So DEM is more near to digital terrain model. Okay. Now, if also DEM also ignores the s- houses and trees, what is the difference between DEM and DTM? We will understand that, but you just basically need to understand that there are three types: DSM, DTM, and DEM. DEM is very similar to DTM. Okay. So it is easy to remember how terrain refers to the bare earth. Okay. Whereas surface refers to any surface. So just remember like it like that. Now, DTM is an extension of DEM, enriched with additional features such as break lines and ridges. Unlike DEM, DTM incorporate finer details, making it particularly valuable for applications requiring a more intricate representation of the terrain. Now, what it means is, so just for example, if there was a river going here, a very small river with a small depression. Okay. Now, what will happen when you create a DEM? It will show no river. It will show no depression here. Okay. Whereas if you create a DTM, it will show a little, it will go like this and show a little depression here. So it is more specific. So when you are doing some application based on the, for example, hydrological modeling or some very specific applications where you need the accurate surface of earth, okay, then DTM is more valuable. DTM plays a crucial role in flood and drainage modeling, land use studies, geological applications, and even extended to planetary science. DSM encapsulates the complete topography, includes both natural and anthropogenic features of Earth. This encompasses building, vegetation, and other structures. DSMs are especially preferred in applications such as telecommunication, landscape mapping, city modeling, and visualization, where a holistic representation of the surface is imperative. Okay, I hope this is clear to everyone. I'll share the link also for your reference. So, to understand the terrain surface of the earth, right, there are some analysis that we do. Some very important things that actually are based on GIS that we can use to do analysis of the earth surface. that is the terrain analysis. So they are called as slope, aspect, hillshade, elevation, contour. Now, elevation you already know that when you have a surface, I explained that each pixel representing the elevation, so it forms a DEM. Okay. Now we will use a digital elevation model to create all these other features. Okay. So let us first load a DEM into our QGIS. So you have a DEM here. Uh, did we demonstrate before in the class how to download a DEM? Or are there people who yet do not know how to download a DEM? Should I repeat the part on how to download a DEM? What about others? Does everyone know how to download a DEM? Okay. You have to simply go to your website, USGS. First, you need to know some DEM types. Uh, famous DEM, yes, types. Okay. So there are many kinds of DEM available to us. Okay. The method to download is, I will explain one of the methods. Just go to the USGS Earth Explorer login. Okay. In this login, first you have to do a login here. Once you log in, just zoom into your place of study area. Click on the use map option here, use map. It will create, when you zoom out, it will create 4 points. Just change the points according to your study area. Now, because we are downloading a digital elevation model, the latest would be the best one, right? So no need to choose a date range. But if you want a DEM from a certain time range, you can choose the date. But DEMs are not generally produced. They take years to be produced. Like it is a very hectic procedure. So maybe let us see for which year the data is available. So I will click on datasets. In datasets, you have to choose this digital elevation model. In digital elevation, you will find SRTM. Okay. In SRTM, you will find SRTM 1 arc second global. So this means uh, this SRTM 1 arc second global, this 1 arc second global is a degree term. It means equivalent to 30 meters by 30 meters. Okay. So you have to select this and click on results. Your criteria resolved into no results. Please adjust your criteria. So if you see, one data is available and it was last taken on 23rd of ninth month of 2014. So it is that long ago. Okay. So you can download your DEM from USGS. Similarly, there are many other free websites. So I showed you how to download the SRTM data. It is by the USGS. Then there is something called as NASA DEM. You can also Google it and look how to download NASA DEM. Then there is something called as ELOS Pulsar. It is by Japan's Aerospace Exploration Agency. Okay, it is a very good digital elevation model. It is like there are no errors in the data. So whenever choosing a DEM, I would suggest use the ELOS Pulsar. Okay. Then we have the Ester DEM. It is also freely available. It is of the resolution 30 meters. Then we have Copernicus DEM, 10 DEM. Okay. So you have different kinds of DEM. So for Arctic area, you have this Arctic DEM. It is of 2-meter resolution. So if you have to download any DEM, you have to look for it. You have to look for the website of it and you can download it. Just as I showed you that SRTM can be downloaded from the USGS website. Okay. Now, once you download your DEM, it will look something like this. Now, we have to understand what is a slope, what is a aspect, what is a hillshade, what is a contour. So, slope is the degree or inclination of the surface. So, for example, if this is a hill, okay, there is a degree of inclination, right? So, from the surface, at any point on the surface. So, for example, if I take maybe this point, there is an angle. This is theta, right? So, there is an inclination of the surface. This theta is called as slope. Now, to calculate this slope, you first need a DEM. You can simply go to your processing toolbox and look for slope. Okay. So in the raster terrain analysis, you will find slope. Double click it. If you want to save it to your computer, you can save it, right? So once you run, okay. Now, why did the product not appear? This is a very important thing that I forgot, and it should be a learned mistake. Whenever you are working with a raster, you first need to reproject it into your local projection system, that is UTM system, because the elevation is in meters, right? This elevation is in meters, and when we do processing on it using the geographic coordinate system. So it is in the geographic coordinate system. This gets converted to degrees and the processing does not give a solution. So I need to remove this. This is first you need to reproject this raster. Projections, warp, reproject. The original is 4326. We want to convert it into the UTM 43N, right? So once you have the reprojected layer, open the slope and run it. So this is how the slope looks. So every pixel on this image represents the slope of that area. So you can visualize it. Go to properties, symbology, single band pseudo color, apply. So this green areas are of the highest slope. The steepest slope are of these green areas. The red ones are less slopes. Okay. So this represents the slope map. Now, why do we actually create this? Maybe you are going for trekking. Okay. So maybe you are going for a trekking in some area. So you can figure out maybe if I go along this red area, that will be more safe. Okay. Because this, sorry, not safe, but you can make a way along it. You can understand your path, right? So maybe if you have to choose if you want to go from one point to another point, going through a steep one is more risky, whereas going through a non-steep area, it would be more normal. Okay. So after slope, what comes next is aspect map. Now, aspect is the orientation of slope measured clockwise in degrees from 0 to 360, where 0 is north facing, 90 is east facing, 180 is south facing, and 270 is west facing. So let me say this is a hill. Okay. On this side is east, on this side it is west. Okay. And north is in the depth of the image, and south is towards you. Okay. So if you think clockwise, the orientation of the slope, if you see this slope, it's oriented towards this side. Okay. So based on the orientation of the slope, maybe the slope is like this, then it will be like this. The orientation of the slope based on this north, east, west, south, it is given 0 to 360 degrees, and it is called as aspect map. So these are used when we are doing hydrological modeling. These are not generally used. They are used when we are doing something modeling or some kind of analysis. Okay. So similarly in raster terrain analysis, you will find aspect here. So just select your reprojected layer and click on create. So this is how the aspect look like. So you can have a feel of how the hills will be looking, in which direction the hills are. So any point that I click, it is between 0 to 360 degrees. It will show me which side is the hill facing. Okay. I can understand the face of the hill from this aspect map. Now, the next thing is hill shade map. Hill shading is a technique used to visualize terrain as shaded relief, illuminating it with a hypothetical light source. Okay. So, for example, these are some hills, and if I place a bulb here and a bulb pours light on it, and you take a image from here, how will it actually appear? There is a hypothetical light source. Okay. So it helps us to understand the terrain better. So to create a hillshade, look for hillshade and double click on hillshade. Look for your reprojected letter. Now, here is the azimuth. It is the hypothetical light source. On what angle do you want the light source? So you can change it accordingly, and the angle at which the light source should be. By default, it is always this. Okay, you can change it accordingly. Now, if I run it, so this is the hillshade. Now, there is one important thing about hillshades. Hillshades are very important. They can help you understand how the actual surface of the ground looks like. So here you can see it is plain, right? Whereas in aspect, it was not so clear, right? In slope, it was not so clear. You have a red color, but you can't understand the direction or the relief of the slope, okay? Just the angle. So you don't know if it is going, the angle is on this side or this side, right? So hillshades are best to have a sketch of the terrain, what it actually looks like. Okay, this part is clear to everyone. Now, next is something called as handling invalid geometries. We will be, if time allows, we'll try to complete it. Otherwise, the rest would be of it would be a homework. I'm sharing the link with you. Now, what happens when you are digitizing? Okay, there are some errors that you create. So, for example, if I'm digitizing in QGIS, maybe I have to create many houses. Okay, maybe in some houses I'll I forget to properly join them, or maybe some are taller than the others. Okay, or maybe if I have to create some grids, I'm creating some polygons. I forgot to delete this extra part. So sometimes there are many errors that you create while digitizing. If you have worked previously in digitalization, you will understand that we create many small problems. There are manual problems that we create while digitalizing. Okay. So we will try to resolve it. So get the data, download the zip file from here. The download archive contains multiple folders. Extract the archive and use the file in the states folder. Okay. So here is the states folder. Just look for the SHP and drag it into your. Let me just choose a new project first. and drag this layer to here. So you have the shapefile of India. browse Browse to the downloaded Indian and expand it. Just simply add it. You will see now Indian states layer loaded into the layers panel. Go to the processing toolbox. We will attempt to run a processing algorithm on the input layer to demonstrate how invalid geometries can cause problems during geoprocessing operations. Okay, so just look at these polygons. From here, you cannot know. Maybe there is 1 inch of a place where you forgot to join the shape and it is not a perfect polygon. Okay, so maybe you are going to apply an operation to calculate the area. Just for example, when creating these polygons, maybe when someone created this polygon, he actually forgot to join it somewhere and there is a little gap here. Okay, that gap, it won't be visible to you. Okay, but when you will do some processing, you will find that there exists a gap. So that is why, because there exists a gap, it cannot be called as a polygon. So they are called as invalid geometries. So the geometry that not aligns with the requirement of us. Okay. So go to your processing toolbox, look for topological coloring. Double click on it. In the topological coloring dialog, select Indian states as the input layer. Keep all the parameters to default and click run. So you will find an error occurred. Invalid features filtering. Now, the topological algorithm implements an algorithm to color a map so that no adjacent polygon have the same color. So these are some polygons. If you apply this topological coloring, all the polygons will have different colors. But because there is some problem here, it did not proceed. Okay. This is a useful cartography technique and the four color theorem that states the four colors are enough to achieve this result. There is, just ignore this. As the algorithm runs, you will see a warning displayed in the log table. Feature in the input table has invalid geometry and was skipped during the processing. The default setting to handle the invalid geometry in the processing toolbox is located at Settings Options Processing Journal. Okay. So first, if you see, we got this error. Okay. So there is a setting inside your QGIS. If you go to settings and options, if you go to settings and options and then processing, let us look for processing and general. So whenever there is a invalid feature filtering, this part is set to skip. So invalid feature filtering, in many of yours QGIS, it would be set as skip. You can change it to stop If it is skip, you have to change it to stop. Otherwise, it will skip it and show as completed and nothing will happen. Okay. So once you change it to stop, back in the main QGIS window, you will see a new layer colored. It did not happen, but there is a new layer. Okay, colored. Notice that the new layer is missing a state which had invalid geometry. I have to first do it with the skip option. So if you see, this color did not happen because there was one invalid geometry. That was this state, that this polygon was not complete somewhere and the complete processing did not happen. Okay. As the algorithm runs, sorry, back in the main QGIS window, you will see a new layer colored added to the layers panel. Notice that the new layer is missing a state, okay, which had the invalid geometry. We now know that the particular state polygon had invalid geometry, but we don't know what the cause was. We can easily find that out. Search and locate for the vector geometry check validity algorithm. So you go here and look for check validity. In the check validity dialog, select Indian states, that is admin 2, select for GEOS and click run. As the algorithm finishes processing, you will see three new layers in the layer panel: valid output, invalid output, and error output. The layer error output contains the location and description of the geometry error. So in this error output, right click on and go to attributes. So it says ring self intersection, right? I mean, there is an error. Maybe you don't understand what ring self intersection is. But to look at the error, you can just double click here. It didn't work. Okay, just click on this. Zoom map to the selected rows. Is this working in your QGIS? So we are unable to zoom it, but there is some error here. Okay. To resolve the error, you will find QGIS comes with a built-in algorithm to fix geometry errors automatically. Okay. So when you have a large data set, you should first do the validity test, and then you can check if there are errors. You can fix the geometries. Okay. Search for the fixed geometry algorithm. In this fixed geometries dialog, select the Indian states and click run. As a new layer, fixed geometries will be added to the layer panel. At this point, the geometry error is fixed and you can run any processing algorithm on this layer without problems. But we can see that there is still a gap between the adjacent polygon that is unexpected and can cause topological error down the line. We can fix this too by editing the polygon. So this can be done by editing the polygon, but we don't actually know where the polygon is. So there is a difference here somewhere. Anyways, so now because the geometries are fixed, now if I use the topological coloring, okay. So now if I use the topological coloring on the fixed geometries, so our algorithm run without any problems and a color ID to each polygon can be used now. So here in attribute there is a color ID added here. So you can simply this time based on symbology categorized color ID classify. You can choose different colors and apply, right? So you have this map. Okay, there is some error in this that we are not able to zoom into our error. But if you find out, let me know. Otherwise, I will look into it and let you know, guys. Okay. So this was today's session. If any doubts, just let me know. Otherwise, we'll meet tomorrow. Okay. So anyone has any doubts? Okay then. We'll connect tomorrow. Take care.